Good morning, Abyss. This is, I don't know, we're a little bit later. It is 9:50. So for the people that are just turning in, here we go. Jackson Browne, one of my favorite songs. Have you heard this song before?
Doctor, my eyes have seen the years and the slow parade of fears.
It's an old person's song.
Now I want to
You'll get used to it.
understand. I have done all that I could to see the evil.
I gotta dress appropriately. I gotta have my hockey detector on.
You must help me if you can.
Huh?
Doctor,
My quality control person did not do a good job this
tell
morning.
me what is wrong. Was I unwise to leave them open for so long?
All right. Hopefully, we'll have our eyes open now for the rest of the period. Whoops. I don't even know how to turn this thing off. Okay. All righty. So we're going to look at limits, and we're going to look at them analytically. And on a quiz, if I ask you to find them analytically, that means you're going to be using algebra. And so as I go through today, you're going to find out what algebra I expect you to show and what algebra I expect you don't have to show if you don't want to. Okay? Now, on all of these, as we get to them, you could use a table or a graph to find the limit so you know that your work is correct. You understand what I mean? You go through all the work, you go, I don't know, I got the answer 1/4. Is there a way I can check it? Yeah, you can put it in your calculator, and lo and behold, you come up with 0.2499999. You're thinking, hey, it's got to be close to 1/4, correct? All right, so we're going to look at some properties first. When we talk about limits, I'm going to get this a little bit closer so you can see. There we go. And we're going to have something called a scalar multiple. We already know these two things. We know that the limit of f of x as x approaches c, that limit is going to be L. I'll give you an example. Let's say that the limit as x approaches 1 of f of x is, I don't know, what number should I pick? I guess I'll pick 3. And we know that we got another function, and it is also headed to 1. So it's headed to the same number, and it's going to have a limit, which I call k. I'm going to use the number 5. Okay? So I'll back this up a little bit since they're getting too big. So this is my general form. This is a more specific form. Okay? So a scalar multiple really means I'm doing this. I'm taking the limit as x approaches c, and I'm multiplying my function by, oh yeah, let's choose 5. Well, that could be written as this, 5 times the limit as x approaches c of f of x. So in other words, I'm able to pull that constant out of here, okay? And that's going to give me 5L, 5 times that limit. So in other words, if I have on my example the limit, and if I use 1 as c of f of x, and I'm multiplying by 5, this is going to be 5 times the limit as x approaches 1 of f of x, and I'm going to get 5 times 3, which is 15. All right? So if a more general form would even be this. If I have the limit as x approaches c, and a is any constant, any what we call scalar multiple of f of x, my answer would be AL. So you should be able to jump from here to here if you know what that limit is. So when there is silence, I think everything's okie dokie. All right? All right, Ryan Zaski? All right, so if I have this, the limit as x approaches c of f of x plus g of x, that's the same as two limits being added together. And I'm going to get L plus K. That's a sum, right? Morgan, you know how I do a difference? I put a minus sign here. And then I put a minus sign here. And then I put a minus sign here. Yes, sir. Up here. All right? So they got to tell you that kind of stuff ahead of time, okay? And they will. So they'll do something like this. They'll say that the limit as x approaches 1, what's f of x plus g of x. And they would have told you this stuff up here, okay? This might be a c, but in the book they'll tell you what those numbers are. And so you could just write down 8, right? And be done. So, okay, I just got to add those numbers. That's all I got to do? Yeah. Is that all the work I got to show? Yeah, because I don't think you have to show me that 3 plus 5 equals 8. Yeah. So if I have this, the limit as x approaches c of f of x times g of x, what do you think you get? Who wants to take a risk? Aaron. You say it again because I quite didn't hear you. This means multiplication, by the way. You're thinking composition. You're thinking open little circle, which we're going to get to on letter G. This means straight multiplication, so it's just an operation. Maya? Yeah, the final answer. It will be 15 when c becomes 1. Okay? So you are right that the limit as x approaches 1 of f of x times g of x would be 3 times 5, which is 15. That is correct. But what if I tell you this stuff right here? What would it be? Not sure? Okay. Emma. K times L? Okay. KL? What? Nope. Nope. Just K times L. Just like mine did 3 times 5, 15. Or somebody could be edgy and go LK. Right? She could have said 5 times 3. That's 15 too. The C is just the value we're approaching on the function. Does that help? Okay. Good questions. Yes, ma'am. No. Because if I'm approaching a different input, I might be headed towards a different number. Okay? Because let's say, I'll show you what I mean by that. That's a really good question. So here's the number 1, right? Okay. 1, 2, 3, 4, 5. And so here's G. This is G, okay? So right here, that's supposed to be 5, okay? And then right here, what did I get? 3. So right here, is F. There's its limit, right? So I'm multiplying those two numbers together. So if I go to 5, well, gee whiz, F will be positive and G will be negative, right? Based on my fancy graph. So you'll get different values because every time you put in, or hopefully if it's a function, every time you put in a different x value, you should get a different y, right? Does that kind of make sense? Let's try this. The limit as x approaches c of f of x over g of x. Hi, what did you find out?
Okay, so I think Claire's going to make the payments. I don't know what she needs.
Yeah?
So, and then she has to fix this too, so it's supposed to say is.
Okay.
So we're going to go around and around and figure out where we can move up.
Perfect.
And then I'll try to start hanging them up today if I have time, and then tomorrow I can hang up the payment.
Good. And you got to get them printed where in the library? Okay. Make sure you tell them that I'm going to pay for them. Okay. Good. So this is the general form, and then let's do this, the actual number. Okay? You get to choose. Do you want to do when I actually know what C is, or do you want to do the more general one for any C? And you get to take the risk to choose which one you want. Yes, Cam. You're doing the what? Okay, what's it going to be? Do you know the limit as x approaches c of f of x? You gotta make sure you look at the top. You're right, it's L. You know it's that number, okay? Okay, as long as k isn't what number? 0. Okay, what about this one? Since I know the actual numbers. 3/5. Am I making this too complicated, or are we okay? All right. Power means this. If I have the limit as x approaches c of f of x to the third power. Anybody want to take a guess of what that is? Cora, do you think you have an idea? L cubed. Perfect. So let's take the limit as x approaches 1 of f of x cubed. Tegan, do you think you have an idea of that? Did you say 27? Yeah, perfect. Okay. So this thing is called a radical. Have you heard those two terms before? This is called the radicand. I think I told you that before, right? This is called the index. Did you know that? And when I simply have this, the index is 2. Would you agree? So, n is even. My domain, Hunter, has to be what? In other words, if this is even, like the square root, the fourth root, the sixth root, the eighth root, what am I allowed to input? Okay, 0 is neither positive or negative. It is considered a neutral number. Can I put 0 in there? You can't take the square root of 0? You can't, because 0 times 0 is 0, right? So what, besides just being positive, I have to include 0, right? So it would look like this. Okay. What about if n is odd? What's my domain? What am I allowed to input? All real numbers, because you can take the cube root of a negative. You can take the fifth root of a negative. So I'm going to write it this way. There's that little epsilon we use a lot. That means all reals. So the answer to this, it looks like this, doesn't it? So I can put c in here. I will get the nth root of c. N is even, then c better be greater than or equal to 0. N is odd, c has to be the element of the reals. So all you have to do is substitute it in there. Aaron, we're now to your problem. Okay? This is a composition, right? In other words, we have a function put into a function, correct? And so what this is going to be is the limit as x approaches c of f of the limit as x approaches g of x. That's what that means. So do I know that, oops, I forgot my c. Do I know that limit? Do I know the limit from above? Do I know the limit as x approaches c of g of x? Did I tell you what that was? Yeah. Okay, so this is equal to the limit as x approaches c of f of k. Alrighty. You okay with that? Okay, now, because I'm going to ask you a question. Okay? This is a function, correct? When I plug k in there, which is a constant, right? Some number, 3, okay? I am going to get one number, right? And it's always going to stay that number, right? Okay? And since that's a constant, when I plug it into the function, I'm going to get a constant, correct? Right? My answer is going to be this constant that I'm given. In other words, in the example that I've given, would be the limit as x approaches 1 of f of 5. Do you see where I get f of 5? Is f of 5 ever going to change? No, because it can only be one y because it's a function, correct? It can't be any other y than the one it gets from the number 1, right? Now, do I know what that number is? I have no clue. So it's always going to stay f of 5 because 5 can only give me one y. Does that make sense? Okay, if that makes sense, you're doing what we call in calculus analyzation. You're thinking through a problem and you're using your idea of logic. Okay? And sometimes it takes a little bit of wrapping your head around it. Okay, can I go on? Okay, this last one's the hardest one. Yes, sir. Okay, I'm going to show you that on the next page. Okay. Let's say this. Okay, you ready? You ready? Let's say f of 5 equals 15. Are you okay with that? Okay, now let's go to the next page. So it's the same as this, isn't it? Right? Okay? So, God, it's like I paid you to come and ask that question. Wonderful. So this is steps to find limits algebraically. Step 1, look for a constant. Okay? So I'm going to do it graphically first. This is a function, okay? In other words, it's like saying f of x equals 15, which is the same as y equals 15, because f of x and y are the same way. Because f of x tells you how to compute y, all right? So in the last example, I don't know how I computed what I did to 5 to get 15, but it gave me 15, okay? What does that graph look like? Looks like this. Right? If I had a table, it would look like this. It's always 15, correct? It's kind of like Peter Pan, never grows up. So over here is 1, here's 2, here's 3, pi is somewhere right here, correct? And I'm approaching pi from the left. Bam, bam, bam. I'm going up to those y values, correct? I'm approaching pi from the right. Bam, bam, bam. I'm hitting those y values. Well, what does that mean? What's y always going to be every single time? 15. So if it's a constant, the limit of any constant is a constant. So if I have this, the limit, because it has no variable, there's nothing that changes it, right? So in other words, if I have k, I'm going to get k. Now, this is a good question. How do I know? It says x approaches c. So x is my variable, correct? So as give you a hint, because you could say, well, Kruger, how did you know a was a constant? How did you know b was a constant? How did you know c was a constant? Because if my input is x, if that's what's changing, everything else is a constant. Are you okay with that? I'll point that out more and more as we go on. So the easiest thing is look for a constant. 2, substitute. That's the second easiest thing. If it does not cause any problems, like division by 0, the square root of a negative number, then I can substitute. So right here, if I plug 4 into here, right, because it's continuous, correct? So that number exists, correct? It doesn't have to exist, but it does in this case. If I plug 4 in there, do I have division by 0? Am I taking the square root of a negative number? None of that. So all I got to do is compute it. So here's my work on a quiz. I just have to write 15. Here's my work to show on a quiz on Monday if I get asked this. Now, you may know what 4 to the third power is. Some people do. Some people are able to go 4 times 4 is 16. What's 16 times 4? Yeah, some people are able to do that. And then they multiply 64 by 2 and get 128. And then they add 1 and get, and they write that down. That's my work. Some people do it on a calculator, because you can use your calculator. But should I see anything? I'm not checking that you can do arithmetic. You understand what I mean? Now, if you get it wrong, you lose the whole point, right? Well, okay. How else did you get 92? I have no idea how you got 92. It should be 129. And you get to use a calculator. You should get 129, right? Some people, like me, like to do it in the head because I don't trust the machine and I might hit the wrong button. Okay? Everybody with me? Easiest two ones. If it's a constant, it's that answer. If you can substitute, I look to substitute right away. Okay? So I look at number 3. And I plug in a -1. I cube a -1, I add 1, I get 0. I take -1 plus 1 and I get 0. I get 0 over 0. Poop. So I go to step 3. Factor. I've been talking a lot about these babies, haven't I? Right? And some of you have remembered, and some of you ignored me. Like, he wouldn't ask us about a binary cube. That would be mean and cruel. 13. Do we remember how to factor this? X starts out with x plus 1. You're always guaranteed. So what you do is you take the cube root of this, rewrite this. So if it's plus, it's plus. If it's minus, it's minus. Take the cube root of that. Which I'm happy to see, by the way, right? But the next thing is you're guaranteed a trinomial, 3 terms. Does anybody want to take a risk in knowing what? Oh, Emma, awesome. What? Is this what you said? Beautiful. That's it. Now, just as a side note, this one would be this. You only get one minus in there. Okay? It's either going to be here, if it's plus, it's going to be, if this is minus here, it's going to be plus here. And all you do is multiply these two numbers to get the middle term. You cannot factor this, folks. You're done. That's as far as it can go. All right? All right? Now, yes, ma'am. Because that's blood drops. I'm killing those two things with swords. Okay. I need a certain amount of violence in my life. Okay. Just to keep me sane. That's why I use red. Blood. If you want a red pen, I give away free red pens. If you're into this, okay? You can stop by afterwards and get one. I have 450 of them. They're all in that drawer. Okay? Okay? A lot of blood in there. Okay? Now, what's down here now? A 1. Everybody agree? So now when I put a -1 in here, I don't have division by 0, do I? I have a -1 squared. What is that? 1. Minus a -1. I'm now to what? 2 plus 1. 3! Ha! Okay, perfect. Right? Everybody okay with that? Are you okay with that? Now, I want to show you something. Let me go back to my discombobulator here. Enter, delete, parentheses. Could you see this okay? X to the third plus 1 parentheses divided by parentheses x plus 1 parentheses. Looks just like that, doesn't it? Right? Make sure my window's the way I want it to be. Exit, draw. Looks like a beautiful parabola, correct? Now, I'm going to go shift trace. And I'm going to put in a -1. Right? Look at, let me back up, exit. Look at that thing. Doesn't it look beautiful? Oh yeah. And on a quiz, you'll draw that picture. Because I'll ask you to draw this function. And you will. But if I go shift trace and I put a -1 in here, oh, let's try this again. Shift trace, let me type in a -1. Look, I get error. Why do I get error? I'm dividing by a 0, aren't I? Correct? What should be in this graph? What? A whole, right? A whole. So this graph should look like this. At -1, there should be a hole here, and it should look like this. That's the equation of this graph. Excuse me. This equation is this graph, correct? Now, oh, I want to go back to this. I want to do this. Let me go to the table. And I'm going to put in -1.00001, right? I'm to the left of a -1. See, I'm getting close to 3, aren't I? I'm going to be -0.9999. I'm to the right of a -1, correct? Ooh, I'm really close to 3, aren't I? Right? Now, menu, come to here, exit, delete, and I'm going to put in this graph, x squared minus x plus 1. Where did I get that? That's this baby right here. Draw. What do you notice? They're the same graph, except when I trace here and type in a -1, I get 3, don't I? Because I have eliminated that division of 0. These two functions are identical functions except at -1. Because I'm not allowed, -1 is not part of the domain here. Right-hand drawer. Bottom, I think. Okay. Now, every number can be in here but a -1, correct? Every number can be in here. So they're identical except for that one value, a -1. The -1 causes problems. It's like if there were 9 kids in your kindergarten class and somebody was having a birthday, like Jim Newman, and you don't get invited because you're a disruptive, you little boy, and all other 8 people are there, you're not part of the domain. You didn't get an invitation. Okay, let's move on. Does that make sense to everybody? Okay, so here, that's a great question. So here's the question. I will ask you to draw this function. Okay? You better have a hole there. Okay? You understand? And you understand why. Okay? And then the other question I'll ask you is for the equivalent function that represents this except at one point. And guess what the answer for that would be? The other one. Does that make sense? Okay, now here's the other thing I want to talk about. And I'm going to do it right over here where I got room because I did it in the wrong place. Holes versus asymptotes. Okay? And let me give you this. First of all, I'll have this. X squared minus 9 over x squared plus 7x plus 12. Okay? So I'm going to factor this. I get x plus 3, x minus 3. And down here I'm going to have, right, they're conjugates. And here I'm going to have x plus 3, x plus 4. Right? Everybody okay with that? Now, at a negative 3, this function is not continuous because I have division by 0. Is everybody okay with that? There is a break at x equals, I am not allowed to put a negative 3 into here because I get 0 in the denominator. Neither am I able to put negative 4 in here because I get 0 in the denominator, correct? But I can also do this, right? So this x equals a negative 4 is an asymptote because it did not get removed. X equals negative 3 is not an asymptote. It's a what? Whole. Both values that cause discontinuity. There are breaks there, okay? However, can I take the limit here at an asymptote? When I have an asymptote, my function is either going to go up or it's going to go down, right? As I approach it, either up to infinity or down to negative infinity, correct? There is, so the limit does not exist. How about here at a whole? Does a limit exist? Limit always exists. We're going to talk more about that later on. So algebraically, how do I know that? I'm able on wholes to simplify the quantities. On asymptotes, you can't. Is that kind of making sense? This is what it looks like graphically for these. And this over here looks like this. Are we okay with that? I'm going to skip number 4 and go to number 5. Okay? And then I'm going to come back to number 4. So my number 4 looks like, we'll do this. The limit as x approaches 2 of x squared plus 7x plus 10 over x minus 2. How you can figure out that limit? What? Factor? Does everybody see why you would factor? You can't substitute, can you? So, the question is, what does that factor to? X minus 2. I screwed up here. I'm going to make this a negative 2, and I'm going to make that a plus 2. Sorry about that. That's my brain not working right. Sorry about that. What is this factor to? This is always kind of a little hint, isn't it? Right? Wouldn't you agree? That it's going to be x plus 2 times what? X plus 5. So this is your work. You can decide whether you want to use a red pen or not. What do I get as an answer? Can I put 2 in there now? Can I put a negative 2 in there now? Thank you. I can, can't I? Because down here I have a 1, right? So I got a negative 2 plus 5 over 1. What am I going to get? 3. The moral of the story is here, if you're not sure, just write down the answer 3. Okay? Because now I can substitute it because I don't have division by 0. Everybody with me so far? Fourth step. Step 4. Radicals. Multiply by the conjugate. So I got a radical here. I'm going to get rid of the equals, and I'm going to multiply by the conjugate. Down here, I'm going to have x. So what is the conjugate to this? Square root, I need that. Square root of what? X plus 4. Okay? The conjugate's going to be right here. This is your first term. This is your second term. So instead of the minus sign, I'm going to have a plus here. A plus what? 2. Because on conjugates, if I have a minus b, the conjugate would be a plus b. And I would get a squared minus b squared. Is it okay that I said that verbally, or do you want to see it? There's no middle term, is there? So I'm going to multiply these two together. What am I going to get? Right, so again, notice I'm writing limit. You have to write the limit again. I'm going to get x plus 4 because those square roots are eliminated, right? So there's my a squared. Everybody okay with that? Minus the product of these two. It's going to be a negative 4, correct? Over down here, I'm going to have x, and I'm going to have parentheses. Oops, I screwed up down here. I don't know why. I should have wrote, but x, square root of x plus 4 plus 2. The top and the bottom get multiplied by the same thing. So I got the square root of x plus 4 plus 2. Because you got to multiply by 1, right? Sorry about that. So, let's take a look at this numerator. What's 4 minus 4? 0, right? Boom, gone. 0's there, right? What's x plus 0? X. So that's gone, right? Massive pool of blood. What's x over x? So this is gone, more blood. And 1 is left over, correct? What was causing me division by 0? The x did, and it's gone. So now I'm going to see if I can substitute 0 into here. So I have 0 plus 4. What do I get? 4. The square root of 4, 2. 2 plus 2 is 4. And so I'm going to have 4 on the bottom, and I'm going to have 1 on top. Now, big mistake. When all this stuff gets canceled, right? Back on the gravestone, I would like to say rather than died, you know, it says, okay, born April 3rd, 1958, canceled, and then have my date. I wonder if people walk by and just laugh. Okay. So anyway, a lot of people make a mistake of putting 0 here and then write down 0 as the answer. That's why I'm bringing that up. Are we okay with that? All right, let's look at another one. Number 6. That's a great question. You would have a hole at 0. Yeah, 0, because it's only 0 here that makes it problematic, okay? And you were able to, and because you were able to simplify it out of there, there's a hole there, as opposed to an asymptote, okay? And this graph right here, this 1 over the square root of x plus 4 plus 2, whatever it looks like, will be the same graph except there won't be a hole at 0. So what I do is, because I graph this, because it's less work, okay, and I put a hole in there. But I put a hole at 0, 1/4, because this is the y value that you're approaching. Is that just like over here I would have had a hole at -1, 3. Does that answer that? Right. Okay. Okay. All right. So let's do another one like this. I had them all written down. I don't know where I put them. Sorry about that. Here it is. All right, so let's take a look at this one. The limit as x approaches 4 of the square root of x plus 5 minus 3 over x minus 4. Can't substitute, correct? I always attempt to substitute first, okay? Can't substitute. So what am I going to multiply by? Square root of x plus 5, what? Plus 3. Does everybody see where the plus 3 comes from? So make sure I write the square root of x plus 5 plus 3 on the bottom. So now I'm going to write the limit as x approaches 4. Down here I have x minus 4 times the square root of x plus 5 plus 3. Up here I'm going to take the square root of x plus 5 times the square root of x plus 5 and get what? X plus 5. I just get that radicand. Minus 3 plus 3. When I multiply that, I get minus what? 9. Most common answer, minus 6. Do you see that? I've done it like a dozen times. So now, is x plus 5 minus 9 the same as x minus 4? 5 minus 9. Yeah, okay. So, boom, got a 1 here. This was the problem child, right, that didn't get to go to the kindergarten birthday party? Didn't get to put the clothespins in the bottle? Yeah, you hold them by your nose and you drop them, right? Oh my gosh, we got to have a birthday party in here in which we drop clothespins in the... And we have these things called milk bottles, okay? People would deliver milk. A guy would be... You didn't go to a grocery store to buy milk. Somebody delivered it to you. You didn't buy bread at the grocery store. Your mom made it. You didn't buy pie at a grocery store. Your mom made it. I couldn't believe they sold bread at a grocery store the first time I saw it. I said, really? You can buy bread at a grocery store? You can buy donuts at a bakery? Wow. So anyway, back to this problem. I didn't hear anything you said. It was funny and I don't get to hear it?
Sorry, you killed the extra kid.
You can take that way if you wish. Okay. What's the answer going to be, folks? Do you see where we get 1/6? And you know you could verify that both in your table on your calculator and graph on your calculator, right? It'll look like type in 1/6 and say, what does that look like as a decimal? 1.16666. See if you get that on your, if you're not sure. Because all of us are at different levels with algebra, right? Did I tell you were going to be learning some algebra here? Yeah, it's a lot of it. So let's go to the next one. And number 5 is simplify fractions. And you go, oh my God, fractions? I haven't done that since I was in 3rd grade and I hated them there. Okay? So here's my problem. It looks awful. Do you see the fractions? Do you see that it has no radicals? I'm going to make this into one fraction. The common denominator, what I'm going to do is I'm going to multiply this side by 3 and this side by 3 plus x. Do you see that? So by silence, that's okay. So I'm going to get this equals the limit as x goes to 0. I'm going to have 3 minus parentheses 3 plus x over 3 times 3 plus x over x. It got worse, not better, Kruger. I'm going to make it better. It's going to be this, the limit as x goes to 0, a negative x over 3 times 3 plus x, because I have 3 minus 3 minus x. When I distribute this, I get this, right? This is where people make a big mistake. They don't distribute the minus sign correctly. Times. I'm multiplying by the reciprocal. What's the reciprocal? X is x over 1. So what's the reciprocal of x over 1? 1 over x. You see that? If this was 3, wouldn't this be 1/3? If this was 7, wouldn't that be 1/7? So, simplify, simplify. A 1 goes here, a 1 goes here. That's a -1, isn't it? So now when I put 0 in here, what do I get as my limit? A negative what? 1/9. Put 0 in here, 3 plus 0 is 3, times 3 is 9. I know you've done work on radicals, right? Square roots. I know you've done work on rational expressions. And there's a little bit of struggle with that. I got that. How much time do I have? No time? 3 minutes? All right, I'm going to do one more problem here. And it's this. The limit as delta x goes to 0. You're going, oh my God, what is that symbol? Like that? That better? I'm going to explain delta x later on. Did you like delta x? No, she didn't like delta x. And so what you can do, and the book does this, you can get the delta x and replace it with h. Okay? See? The limit as h goes to 0. So this is going to be x squared plus 2xh plus h squared. So I looked at this as x plus h, and I expanded it. Do not write x squared plus h squared. It has a middle term, doesn't it? Minus 2x minus 2h. Remember, I'm replacing that with h in my head so you guys don't feel bad. Minus x squared plus 2x minus 1. So I distributed the minus sign all over h because I got rid of the delta x. I have a whole bunch of blood. Bam, 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 bam. Oops, I forgot one thing here. It's supposed to be a plus 1, and so I forgot my plus 1. That's my screw up from the problem. There's a plus 1 there. Bam, bam. I should have wrote a plus 1 in there. That was my screw up. Blood all over the place. Big pool. So what do I have left? The limit as h goes to 0 of 2xh, that's this term, plus h squared, that's this term. This is dead. We'll finish this tomorrow. Okay? I'll do that all over tomorrow. You guys have a pleasant day. For everybody that's out there in the abyss,